In this video, I am going to derive an expression for the time of flight of the projectile, not only for this one, which is thrown at an angle, but also for this one, which is thrown horizontally. And I will explain you the expression of the time by two methods for this projectile motion. And so let's start. Let's assume that this ball is thrown at an angle 70 degree, as you also see. So in the start, like this is a maximum velocity, instantaneous velocity. And what will happen? It will move in this parabolic path in absence of air resistance. You know that this will be the trajectory. So let's start with method 1. As you see that we have thrown this ball at an angle theta which was 70. Okay, but generally if it is theta, so then this will be the vertical component, right? So this is u sine theta, which will decrease with the passage of time due to the gravity, and this must be u cos of theta. So as the ball is going up, now you can see I'm going to draw the smaller vertical arrow, and at the maximum height this ball will not stop because it have still some velocity due to the x component of initial velocity, but the vertical velocity is 0. Okay, because the ball is not going further high. So we are going to utilize these two positions in our method 1. Okay, so what is our method 1? We, of course, we will apply suat, okay, because acceleration due to gravity is negative g. So if I consider this one is a final position, and this is of course the initial position, so let's apply this equation. V is equals to u plus a t, right? So we can say v phi is equals to u phi plus a phi t. Okay, we have transformed the Suat equation for vertical motion. Okay, vertical component of motion. So what is a vy? Because we have considered the maximum height as our final position, so it is 0, and initially it is u sine of theta plus acceleration due to gravity is negative g, and the time is t. This is a time that is to reach the maximum height, the ball will take to reach maximum height. Okay, so if we move it to the other side of equation, so that will be positive gt is equals to u sine of theta. Okay, so you can also say it's a half time. Okay, because ball will take same time, exactly same time, because this is a uniformly accelerated motion. And in fact, interesting thing, if you take at the same level, the if you see the ball's position at this point, the ball will have the same vertical speed, right? But downward, the direction is downward. Okay, and just before hitting the ground, this is a maximum vertical velocity that is in magnitude again equals to u sine theta. Okay, so what is the half time that we have got is u sine theta over g. So this is the same time the ball will take to reach the ground. So the total time, so what is our time of flight? That is u sine theta over g plus the same u sine theta over g. Since it's a two-dimensional motion, that's why you see sine theta component factor. Okay, otherwise if you are throwing a ball vertically upward, then it will take u over g to reach the maximum height, and then take u over g to return to the same position. Okay, in the one-dimensional motion. So the total time is 2u sine theta over g. So this is the total time. Okay, now let's go to the method 2, and then we will discuss this projectile motion. So in this method 2, we will consider of course some other equation of motion, and that is this one, s is equals to ut plus half at square. Okay, now while applying this equation, we will consider the whole motion of the ball. Okay, because in the method 1, I consider the maximum height of the ball as a final position. But if I'm considering the whole path of the ball, so then it means now this time this is of course the final position. right? And this is obviously initial position. Okay, so when the ball will finally reach the same position, okay, vertically same position, not horizontally, okay, we have thrown the ball from the ground, the ball has reached back to the ground, although it has covered horizontal distance, but right now we are just finding out the time, and for the time, vertical component of velocity is important. Okay, so we will consider vertical component of motion. So let's write our equation for the vertical motion, vertical component of motion. So that is initial velocity, the time t, plus 1 over 2 a by t square. Okay, so we are applying the equation of motion. So what is important, what final position you are taking. So I had already explained you the final position is a ground, so it should be 0. Okay, because the displacement is 0, vertical displacement is 0, and this is obviously u sine theta. Okay, the time is t plus 1 over 2 into negative g into t square. So you can take this thing to the other side, and that will be equals to 1 over 2 gt square is equals to u sine theta into t. Okay, now you can cancel out this t with this one. Okay, and what we got now from this, g over 2 into t is equals to initial velocity along y-axis. So by adjusting it, you can take the 2 on the other side, and g also you can divide on the other side, so it will be 2 u sine theta over g, right? So you can see we have got the same thing. Okay, but now we are going to the next type of projectile motion, which you can also say horizontal projectile motion. Now remember, these, we cannot apply this method. You can't say that the time will be equal to u sine theta for this over g. Okay, we have a different approach for this. Obviously we will apply suat because these both projectile motions are uniformly accelerated motion. So without wasting our time, so let's dive in this question. If you have thrown the ball horizontally with some velocity, so this u is your initial velocity, and we see that there is a no component along y-axis because the ball is thrown horizontally. So once again, under the influence of gravity, the ball will move along this path. So before hitting the ground, how much vertical distance the ball has covered, right? Because we are calculating time, we can find from horizontal velocity also, but I will tell you later. So let's say if this is a height of this cliff, so how much time the ball will take, let's apply the equation of motion. So which equation? S is equals to ut plus 1 over 2 at square. Okay, so if you see how much displacement covered by the ball, that is negative h. Why negative? Because the ball has moved down vertically. I mean, if you see the vertical component of motion, how much ball has covered, it has moved negative h meters downward. Okay, all right, so is equals to, what is the initial component of velocity? That is 0. The time is t plus 1 over 2 into negative g into t square. Okay, now in the next step we can cancel out the negative sign. So how much time the ball has taken, that is 2h over g and square root. Okay, in some question, in your multiple choice question, they can ask you to find out what is the height of the cliff. Then you can use this equation 1 over 2 gt square. Okay, now another, just last, okay, just stick to the video. There's another method. Okay, the method number 2. Let's say if you are given this horizontal distance, let's call it x, right? If you are given this distance in meters, let's say 200 meters, okay, and you are asked to find out the time, so you can simply write, because we know that the horizontal velocity is not changing. Okay, it will not change. So you can simply apply this equation, that the distance covered is equals to velocity times time. Okay, so the t will be equals to x over u cos of theta. Okay, so these are the equations. They can help you to find out the time in both of the projectile motion. See you in the next video.